Good morning, students. You are welcome for the second episode. In the last class, we discussed about what is actually force. From our experience, force is actually a push or pull which can move a body, change its direction, or can make a change in its shape also. Now we want to discuss about more about force. Among that, all is contact force. That means, suppose you want to lift a book. Can you lift it without touching the book? Or you can move a chair. Is it possible to move it without touching it? In this case, without touching, we cannot move our book or a table, or we can draw water without touching, or lift a bucket of water without touching it. In this all case, we want make a contact with it. Sometimes by using a rope or with a stick or etc. Such type of force is contact force. Now we will discuss one type of contact force is muscular force. Suppose when you lift a bucket of water, actually that force is exerted by our muscles. When we chew food into small pieces in our mouth, our teeth does the work with the help of muscles. When food is digested, it is with the help of intestine. There is so many movements of food is taking place. There is also a muscular force. That means any kind of work which we do with our muscles, and such type of force is muscular force. It is also a contact force. That means force which we exert with the help of our muscles or any other types with a direct contact with that body is a contact force. Now another force we can discuss about friction. When a moving ball that gradually comes to rest, or a bicycle, when we stop pedaling, after some time that cycle will come to rest. Or a scooter or car, when we off the engine, after some time that will come to rest. Here all, there is a force which opposes motion. Can you experience that force directly? No. But there is a force that comes to act in between the two surfaces of contact. There is a force which comes in action between the two surfaces. That force brings the body to rest. Such type of force is a friction, and that frictional force is also a contact force. Frictional force is also a contact force. Frictional force, the important things you want to remember about frictional force is, whenever there is a motion, always there is a frictional force. Whenever there is a motion, there is always a frictional force which acts opposite to the direction of motion of the body. In which direction is moving the body? Suppose the body is moving east, then the frictional force is acting to west. If the body is moving north, then the frictional force is to south. That means frictional force is always opposite to the direction of motion of the body, and it acts between the two surfaces. Suppose a body is, when I am writing or giving a tick mark here the chalk moved from one point to another. The frictional force, that means this is the moment of body direction, but the frictional force is just opposite to this one. That means friction is the force. See, when we draw this line here is a contact. So friction is a contact force, and it always acts opposite to the direction of motion. Now once again you remember about what are the properties of contact force. A force which comes into play when two surfaces are in contact. A force which comes into play when two surfaces are in contact. That means the body which is moving, suppose we are pulling, that is a contact force. Then another one is muscular force. Any kind of work which do with the help of our muscles. Any kind of force which we do with the help of our muscle is a muscular force. And there also can exert muscular force. For example, a bull cart pulling a cart by bulls, or a horse pulling a cart. These are examples of muscular force exerted by animals. Now, third one is frictional force or force of friction. Can you say in which direction is the force acting? Is it the direction of motion or opposite? That force is always say it is in the opposite direction to that of the motion. Where that force comes into play? Where that force comes into play? That force comes into play between the two surfaces, comes in contact. These are the things you want to remember about contact force. Examples: muscular force is a contact force, frictional force is a contact force. Now we can go to another type of force, non-contact force. Example, you see. Here, a magnet is suspended in a thread. Now I am going to bring another magnet towards it. Is the force exerted here actually in between contacts? Yes or no? See once again. Here is the magnet suspended. Now I brought another magnet towards it. See, is any contact now? Is the body is coming? See, now here the force exerted, but without the contact. Once again, now just reversing the pole. Here is the previous pole, and the pole of this magnet is reversing. See, that side is moving backward. You can see. That means you already studied like poles repel and unlike poles attract. But that force is not in contact. That force acting without a contact. So that type of force is an example of non-contact force. That is an example of non-contact force. The force of attraction between two magnetic poles or force of repulsion between two magnetic poles are examples of non-contact force. Are examples of non-contact force. Now another force is electrostatic force. Electrostatic force. See, for this you want to do one activity. Take a straw and cut into two pieces. and suspend one of the straw, then another piece of straw. After rubbing in a paper or dry hair, bring towards the first straw. You can see that the first straw is attracting, and if the second straw and attracting and that come into contact, because you know now by rubbing one of the straw getting charged and another one is not getting charged. That means a charged body is attracting another chargeless body. A charged body can attract a body without a charge. Once again, a charged body can attract a body without a charge. Now, the first straw again keep there and another straw is also charged. Now, both of that get charged, and now you can see that unlike a charge, they are developed also attracted. From this, you can understand that the force is not a contact but a charged body can attract From this, we can conclude a charged body can attract another charged body, or a charged body can attract a body without a charge. A body without a charge. Here also, that body are not actually in contact. So, electrostatic force is also an example of non-contact force. Now, two examples we discussed about the non-contact force. One is magnetic force. One is magnetic force, and second one is electrostatic force. Second one is electrostatic force. Now, next one more force we want to discuss is the gravitational force. Gravitational force. Suppose I am going to drop a piece of chalk. Just I am going to release this piece of chalk. Now that piece of chalk fell down. Why? Because that chalk is attracted by the earth. That piece of chalk is attracted by earth. Because of that it fall down. Now such type of force, any body is attracted by earth, that is all the bodies are attracted towards the earth, and that force is called force of gravity or simply gravity. That means suppose a coconut fall down from a coconut tree, it just falls to the earth, or a mango or an apple, etc. After living from the plant comes to the earth because of the force of gravity. Force of gravity, or simply we used to say it as a gravity. Now see more about this gravitational force. This gravity or gravitational force is not only between earth and the body in the universe. Every two objects when we consider in the universe means not our earth only, the sun, moon and all other stars, etc. all together is called universe. In the universe, every two object or body, even if it is small or big, they attract each other. In the universe, every two body when we consider, sometimes it is very small, sometimes it is very large. Even though without their considering their size, they attract each other, and that force of attraction is called gravitational force. That force of attraction is called gravitational force. Once again, what is the gravitational force in the universe? When we consider every two or any two body, they attract, even it is small or big, they attract each other, and that force of attraction is gravitational force. Gravitational force is always attractive. Gravitational force is always an attractive force. There is no repulsive force. It is an attractive force. But electrostatic force can be attractive or repulsive. Electrostatic force and magnetic force can be attractive or repulsive. That is magnetic, when we consider when two like poles, for example, two north comes together, they repel each other, or two south come each other, they repel each other. A north and south they attract. So magnetic force is attractive as well as repulsive. Similarly, electrostatic force is also attractive force when two unlike charges, means a positive and a negative charge come close to each other. But if a negative and negative or a positive and positive, they repel each other. So magnetic and electrostatic force can be attractive or repulsive. But gravitational force is only an attractive force. Among these all forces, gravitational force is the weakest force. Which force is the weakest one? Gravitational force is the weakest one. Okay. We discussed about two different types of force. One is contact and another one is non-contact force. Among the contact force, we go through muscular force and frictional force, and about non-contact forces such as gravitational, then electrostatic, magnetic, etc. Now we are going through another term, that is pressure. Let us discuss about pressure. See, this is a nail. It's a two end you observe. One end is with a sharp end. Another end you see here. This end with a broad area. Suppose if I am trying to pierce or push these two ends with this nail. See, now this end is coming out through this paper, and now I am trying to do the same things with this side. Is it possible? See, I am exerting a very large force, but this is not going through this paper. Now, see what is the difference between these two. For the sharp end, area of that end, for sharp end, area is very small, but this side area is large. Now we want remember about force and pressure. What is the relation? Actually, pressure is the force acting over a unit area. Pressure means force acting over a unit area. So, pressure is equal to force by area. Here, area is in the denominator. So, as the area increases, what will happen? Pressure will decrease. So, when area increases, pressure decrease. As if area decrease, then what happened? If area decrease, pressure increase. Here you see, here area is very small. This sharpened. Here area very small because if for the same force, suppose we are applying 5 Newton force. If area decrease, pressure at that point is more. When I try to push this nail through this paper, this end goes through this because here, see, area of this end is small, so the pressure acting at this point is large. But for the same force, if I try to push through this, it is not going because area is large, so the pressure at that point is small. Now you can go through another example. In your school bag, the shoulder belt is large. Why? Because when you take more books in it, the weight of the bag will increase. If the shoulder belt of the bag is small, then the pressure will be more, then you will get a pain. Because of that, to avoid that pain, the area of that belt is made larger, hence the pressure there will be smaller. Now once again, pressure means actually what is pressure is the force acting over a unit area. You know, the unit of force is Newton. Unit of force is what is actually Newton, and unit of area is meter square. So its unit is Newton per meter square. Newton per meter square, or this we can write N m raised to minus 2. This Newton per meter square we used to say as Pascal. Newton per meter square is called Pascal. So what are the things you want to remember about what is actually pressure? Pressure is the force acting over a unit area. Hence, in a mathematical representation, we can write a pressure is equal to force by area, or P is equal to F by A. And here unit force Newton and it's meter square. So Newton per meter square of Pascal is the unit of pressure. What is the difference between pressure and force? Actually, pressure is also force. But what is the difference? It is the force acting over a unit area. Force acting over a unit area is actually pressure. Okay. Now you try to find out more examples. What are the methods we used to do? Some place where we used to increase pressure. For example, our knife. When we make a knife with a sharp end. Why? Because that sharp end pressure is there is more, so we can cut easily vegetable and other things. And some other case, for example, foundation of the buildings or basement of the building, we used to make with a large basement because when area of that basement is large, the pressure acting on that basement is less, hence the stability of the building is large. In this way you can find more examples because heavy trucks carrying more loads with more wheels. Why? Because if there is more wheels, area can be increased, their pressure can decrease, so the wearing out of tire we can reduce. So now from our discussion we come across what are the two different types of force. Among that, one is contact force and another one is non-contact force. Also you know the difference between the, now another thing is pressure. Pressure is the force acting over a unit area, and its unit. And now